So now let's discuss quadrilaterals. This is still part of our plane geometry series. Okay, so let's define in general what are quadrilaterals. From the prefix itself, quad meaning four. So a quadrilateral having four sides. It's a polygon with four sides. We generally call it a quadrilateral. But they can also be called a tetragon or a quadrangle because of having tetra four gon sides, then quadrangle having four angles inside or interior angles. So quadrilaterals are used commonly in architecture, art, and design. Let's take a look at what the parts of quadrilateral. What are the parts of the quadrilateral? So we have the sides basically. So these sides are the ones connected connecting our vertices. Our vertices are your corners, no? And then interior angles, the one inside. Uh, Usually interior angles are the angles na between sides, okay? And then in their vertices, it's basically the included angle between the sides and the vertex or that corner. It's formed inside interior angles, and then for quadrilaterals, we refer to the base and the height or the altitude as what you mentioned, what an altitude before. Usually, we use this for area calculations. And then, again, your diagonal, same with our discussion with polygons in general. Diagonals are line segments that connect non-adjacent vertices. Okay, because adjacent vertices are just simply your sides. Let's take a look at your classifications of quadrilaterals. So we have a parallelogram. Parallelogram in general is defined as quadrilaterals with two pairs of parallel sides. So basta dalawa ang pares ng parallel sides, it's a parallelogram. Okay? Then we can further classify it as rectangle. If you have two sets or two pairs of parallel sides and you have right angles as your interior angles. All of the four interior angles are right angles. We call them rectangle. Okay? But we can specifically say or classify further if the rectangle has equal sides. All of those four sides are equal, then it's considered a square. Alright, so we can say that a square is a rectangle, but a rectangle is not a square because a square is a very more specific concept. Same as with a rectangle is a parallelogram, or all rectangles are parallelogram, but not all parallelograms are rectangles. Okay? Going back with your parallelogram, it can be a rhombus. Okay? So, a parallelogram with equal sides. So, it doesn't say anything about the angles, but as long as the sides are equal, um, nothing to consider about its angles. Rhombus is consideration natin. Kapag isa lang ang set or pair ng parallel sides, it's trapezoid. Okay? Then trapezium has no parallel sides at all. Okay? So let's take a look at the properties of a parallelogram. So again, ang general definition, it has two pairs of parallel sides. So the opposite sides are usually equal, and then the opposite angles are congruent. So when you say opposite sides, so basically not those connected by vertices, it's the other way, it's the other side or opposite, the one that's parallel. Tapos, when you talk about its angles, its interior angles to be specific, the opposite angle on the other side is usually congruent. Okay? And then, adjacent sides should be supplementary or equal to a sum of 180 degrees. When you connect the diagonals, so usually for quadrilaterals, you have two diagonals. Those two diagonals bisect each other. So, their intersection is the midpoint of both diagonals. So, each diagonal that we write on a parallelogram divides the shape into two congruent triangles, or same exact triangles, basically. Okay, we now go to the next one. So let's have rectangle, square, and rhombus. Okay, so a rectangle has all equal diagonals and has right angles inside. Okay, so what is its difference with the square? A square is the same as a rectangle, but all sides are equal. All right. If all sides are not equal, but they have the same equal diagonals and right angles for the interior, then it's just a rectangle. Then rhombus. Okay, so if all sides are equal, then diagonals are perpendicular, then we can say that rhombus. We can say it's a rhombus. Okay, when the last bullet says that it's a special case for a square that is both a rectangle and a rhombus, take note that a square, sabi natin, all sides are equal and it's a regular polygon. So, equal diagonals and right angles. So, both satisfies the definition for a rectangle and a rhombus. No? So, that's what makes it special. Okay? Then, also have trapezoids. So, we mentioned trapezoids only has one pair of parallel sides. Then we have an isosceles trapezoid. So just like an isosceles triangle, um, those um, those sides that are not parallel are usually congruent in terms of length. Therefore, in that case, if the other pair is a parallel lines, then there will be base angles that will be formed by the non-parallel with the parallel sides, no? So, if ito yung parallel, tapos isosceles, ibig sabihin same yung haba or length. So, these angles inside, these are your base angles, will be congruent as well, or equal. Then we have a right trapezoid. A right trapezoid has two right angles. So, something like this one. Okay. So, still, one set of parallel, then this is your non-parallel, but this will be 90 degrees because it's a right trapezoid. Okay, so usually you can see these trapezoids in bridges, no, or roofs like trusses. Okay, next is a trapezium. A trapezium doesn't have any parallel sides. It's an irregular quadrilateral, and usually the area requires general quadrilateral formulas. Let's go for the formulas. So to get the area of a parallelogram, so we basically have just simply base times height. All right, and then if you have your angle, base angle, you can have AB sine theta for your area. Okay, some anyway, it's like if you have a parallelogram, for example, this is parallel, and this is parallel. In this case, you can just simply cut this part, and then it fits just right here. That's why it's base times height. Okay. Then for a rectangle, definitely it's just base times height. And then for a square, it's a squared, whatever a is your edge or yung side, kasi pare-pares naman all throughout. Then for a rhombus, okay, you can have the area by multiplying 1/2 multiplied by the diagonal 1 and the diagonal 2. Then for a trapezoid, it's 1/2 times the height times the sum of your base 1 and base 2. Base 1 and base 2 refers to the parallel sides of a trapezoid. Okay? So yes, let's continue with your angle properties. So when you sum up your interior angles for a quadrilateral, it should lagging 360. It should always be 360. And this will be very useful in problem solving and also in writing your proofs if you remember your proving. So each classification of your quadrilateral has definitely unique angle relations. Let's start with, or let's answer the following. Okay, so when you try to find the area of a square with diagonal 15 units, so yeah, let's start with that one. This is your square. It has diagonal of 15. So this is 15, but it bisects. So this will be 7.5, 7.5. And this is 7.5, 7.5. Okay. So in that case, we also know that diagonals are right, right central angles, basically. So in that case, we can get one triangle and write it this way. This is a right triangle. This is 7.5. This is 7.5. If these sides are equal, then we can say that it's an isosceles triangle. Okay? And then both of this has the same angles. Right, a right isosceles. So basically, these are just 45, 45, 90 triangle, a special triangle. So your hypotenuse will be 7.5 square root of 2 based on our knowledge on special triangles that we learned previously. Okay? And what we are asked for is, we are being asked for the area of this square. Okay? So, since we made 4 triangles, you can simply get the area of this one triangle and multiply it by 4. Because area is basically just additive of those 4. No? So, 4 times the area of the triangle, which is 1 half base times height. So 1 half times the base, which is 7.5, and then the height is 7.5. Right? So we can cancel this out. This becomes 2, and then 7.5 squared will just be multiplied by 2. So when you multiply 7.5 to 7.5, we get 56.25, and then you multiply it by 2. So this will get you to area of 112.5 square units. That's for the first bullet. Second bullet, trapezoid with bases 8 and 12 and height of 5 meters. What is the area? So these are your bases. So let's say this is your 8m, this is your 12m. So you have your, and then your height of 5m. So what is the area? Remember the formula, 1 half times base, times height times base 1 plus base 2. Okay? So 5 times 20, 8 plus 12 is 20, divided by 2. Then this is your area as 50 square meters. Okay? That is our answer for the second bullet. Okay? Okay? Moving on with the next point. You have a rhombus with diagonals 10 and 12, and then you were asked for the area. Okay? So when you have a rhombus, then this is 12 and 10. So let's say this is 6, 6, this is 5, 5. Remember that their formula is 1 half times the diagonal 1 times the diagonal 2. So it will be 1 half times 10 times 12. Okay? So we can just simply cancel this out. It becomes 6 times 10, it's 60. square meter. That's our answer for bullet number 3. This is bullet number 2. Okay? And then lastly, on the last point, it says, does a trapezium always have equal angles? Since there will be no parallel lines, there will be no symmetry in terms of the angle. So definitely, they won't have any equal interior angles. Okay? So that is pretty much quadrilaterals. If you like this video, just give it a thumbs up, subscribe, and you can share this to anyone who is trying to learn quadrilaterals. And if you have questions, just simply comment them down in the comments below. Thank you for watching. Enjoy the rest of the day.